something about NaCl, that is electrolysis of 10% NaCl solution, also called as brine solution. When electricity is passed through brine solution, that is 10% NaCl, it decomposes to form sodium hydroxide, an important basic compound. How? Let's understand. First, we will see the meaning of the word electrolysis. Electro is electricity and lysis is breaking or splitting. So, we are breaking this compound in presence of electric current. Next, we have used 10% NaCl solution. How we do this? We take 10 gram of NaCl and dissolve in 100 ml of water, which will give us 10% of NaCl. What to do with this? We are going to pass electric current to see what happens. For that, we take beaker which is filled with 10% NaCl solution. We have two rods which are carbon rods and we put test tube which are inverted. Why? Of course, to collect gases which form during the reaction. We are learning electrolysis, so we need power, we need source. Battery, which will have two terminals, one is positive and other one is negative. We are connecting this battery two terminals with electrode. So now one electrode is positively charged, another one is negatively charged. Negatively charged electrode is called as cathode and positively charged electrode is called as anode. So we have one positive electrode, another negative electrode. Let's pass current now. When we pass current, NaCl will split into Na plus and Cl minus. Similarly, water will also split into something. Water will split into H plus and OH minus. So we have two positive ions and two negative ions. Now these two positive ions will go to cathode. When they will go to cathode, what they will do? Cations, that is positive ions, move towards cathode and compete to gain electrons. They want to become neutral, so they will gain electrons. What will happen to anode? Cl minus and OH minus, that is anions, negative ions, move towards anode and compete to lose electrons. Again, why? To become neutral. What happens after that? At the cathode surface, you see some evolution of gas and this gas is hydrogen. Now, let's understand how. Hydrogen wins out Na and H2. May say, hydrogen will win and it will go to come out as hydrogen gas. Similarly, we have two negative radicals formed at anode, Cl minus and OH minus. Let's see who wins. This time, chlorine, that is Cl minus, will win and release in the form of chlorine gas. What is left? Na plus and OH minus. What is left in the beaker will combine to form NaOH. So, Na plus and OH minus combine to form NaOH in the solution. Let's summarize by writing reaction. NaCl, aqueous, that means we have dissolved that in water. It splits and it gives NaOH, that is aqueous solution of NaOH, along with the release of two gases. One is chlorine gas, another is hydrogen gas. To balance the reaction, we have to write here 2 as well as there 2. With this, the reaction is balanced. Let's study something most important about NaCl right now. This process is called something. This process is called chlor-alkali process. Nothing is given along with this name, so we are not going to study anything extra about this. Let's move ahead and study something extra. Here, chlorine is liberated at the anode and hydrogen liberated at cathode along with the formation of NaOH. Let's go ahead and study electrolysis of molten NaCl. When we say molten, there is no water in it. Let's understand what is molten means. When salt is heated at a very high temperature, the molten state is also called as fused state. NaCl is able to conduct electricity even in fused state. During electrolysis, chlorine is liberated at anode and sodium is deposited at cathode. Let's see how. For that, again we take a beaker and beaker is filled with fused NaCl. That is NaCl heated at a very high temperature. Again we introduce two rods. On top of that we put inverted test tubes for collection of gases. We need power supply. Power supply battery will have two terminals, positive and negative. That is how electrode also will develop a charge. One electrode is positively charged, another one is negatively charged. Negatively charged electrode is called as cathode and positively charged electrode is called as anode. What happens after that? When we pass electric current, NaCl splits into Na plus and Cl minus. Na will go towards cathode and Cl will go towards anode. Na will gain electron and form sodium metal, which is grey in color, and it will start depositing on cathode surface. Chlorine will lose electrons and it forms chlorine gas, which is yellow in color. What happens after that? Let us understand. We write a summary of this reaction. That is electrolysis of NaCl in the solution form and in fused state. When electricity passes through NaCl solution, that is brine what we say, we have three products. One is NaOH, second is chlorine gas and third is hydrogen gas. To balance the reaction, we write 2 near NaCl and 2 near NaOH. 2 near water. With this particular reaction is balanced. Now what happens at anode? Chlorine gas is liberated at the anode and at cathode hydrogen gas is released along with the formation of sodium hydroxide. When we carry out electrolysis of molten NaCl, let's see what are the product formed. NaCl, now remember we have not used water, so we use molten NaCl. It's just going to break into Na plus and Cl minus. So here at anode, chlorine gas is liberated and at cathode you will find sodium is deposited. So with this we finish the study of sodium chloride. Let's learn more about salt in the next module.